So everybody, welcome to a very special Midsummer Lusk Research Seminar. It's my pleasure to welcome Kala Sridhar, coming to us all the way from Bangalore, only she is actually currently a research fellow.
A Fulbright.
Through the good offices of the Fulbright. And I like Fulbright because my daughter had a Fulbright fellowship, which she spent a year in London, but she's visiting at the Luskin Center at UCLA, and she has done wonderful work on urban economics generally. She's published widely in all the journals that we sort of read. I noticed in her bio that she's in the top 10% of all SSRN downloads, which shows people read her stuff, which is the most important thing. She was also kind enough to host me in Bangalore, and we were just discussing this about 8 years ago, and it was a wonderful, I very much enjoyed my time there at the Public Policy Center there. And so she's going to speak on a subject that's very near and dear to my heart, which is the spatial structure of Indian cities. Spatial structure of Indian cities is very much shaped by regulatory factors as well as market forces, and probably have to say unusual geographical characteristics as well. And so I'm eager to hear how all of those things work together to make Indian cities as they are. So Kala Sridhar, and she has her PhD from Ohio State. So she has, I hope, fond memories of a good amount of time in the United States. Please take it away, Dr. Sridhar.
Okay. Thank you very much, Professor Green. First of all, I would like, so am I audible to everyone? Loud and clear?
Looks fine.
Okay, thank you. So first of all, I should thank Professor Green for this wonderful invitation to speak at USC's research seminar series as part of the Lusk Center for Real Estate Research. So I'm really honored and privileged to be here, and I want to thank him for the invitation. And I would like to thank Fulbright program for funding this fellowship research. And there's an entire team consisting of my GIS consultant and others in India that have helped me with the work. And this research is joint with Pavo Mankonan at UCLA Luskin School of Public Affairs, where I'm currently based as a visiting Fulbright Nehru Fellow. And the standard disclaimer applies, which is that any errors remain ours. So for the first few slides, if I may, I'll just talk a little bit about my institution back home institution in India. And I'm a professor at the Institute for Social and Economic Change in Bangalore, and which is an all India interdisciplinary research institute for social sciences set up in 1972. And it undertakes a lot of pure and applied research in various areas of social and economic development. We do a lot of work for multilateral funding organizations like the ILO, the World Bank, the ADB, and the United Nations. And we, of course, help the government of India and the state government of Karnataka in their policy making. And our flagship product is the PhD program, by which, out of which about 250 PhD students have graduated thus far. And we have 9 academic centers. Mine is the Urban Center, on agriculture, urban, social, sociology, economics, political science, ecology, population, human resources, and decentralization. And the institute has its own journal, which is a Springer journal called the Journal of Social and Economic Development. And we have very eminent economists every couple of years nominated as BKRB Rao chair professors. And these have included many professionals, many well-known scholars like David Bloom at Harvard and Geeta Gopinath at Harvard University, Ashutosh Varshney at Brown University, Michael Walton again at Harvard, and so forth. The Center for Research in Urban Affairs, at which I'm a professor, was set up in 2014. And basically the focus of this is urban development and policy, urban governance, suburbanization, part of which I'm going to present today, and urban environment. Some of my colleagues work on the impact of ICT and so forth. And we also study finances, city finances and service delivery. And we have done a lot of funded projects for the World Bank, the ADB, the Indian Council of Social Science Research, and Azim Premji University, the Government of Karnataka, Government of India, and the Human Settlements Management Institute. And I thought one thing that would be of interest to this audience is an annual month-long international postgraduate program on the urban environment for students of Nordic countries. That actually this year it was on hold because of COVID, but otherwise every year it is a month-long program for which various students from the Nordic countries come and reside there at ISEC for a month for this course. And as far as our center is concerned, there are about 12 PhD students, out of which 5 of them are working under my guidance. So it is a lot of work. And my broad and specific research interests are basically urban regional economic development, regional disparities, municipal finances, and I'm also interested in India-China comparisons, and as also the impact of ICT and their impacts on cities and their economic impacts. And my current interests are the effects of digital homestay platforms such as Airbnb on housing in India cities, suburbanization, sustainable finances, and also on urbanization in the global south, consisting of these countries, Brazil, China, India, and so forth. And some selected recent books is one on India and China, The Rise of India and China, which came out of Routledge last year. And one book on urban transport governance came out of Springer last year. And one book which has been widely cited and quoted is The Paradox of India's North-South Divide, which is a co-authored book. So now coming to this actual research, which I'm presenting here today, the motivation for this work is to understand why it is important to know or examine the spatial distribution of population and employment in India's cities. And the most important reason for this is the urban planning and land use, right? And I don't know, Professor Green has visited India many times, so I don't know about how much of India the others know, but let me mention that urban master planning in India is a very, very complicated and long-drawn process. Long-drawn in the sense that it takes about 4 to 5 years for the master planning process to complete, because they solicit public inputs, expert feedback, and then they revise it again, then put it up for review and approval and so forth. So by the time that the master planning and the land use planning and the zoning and all those things take place, the city's actual growth has actually surpassed all projections and all predictions, right? So it's very, very difficult to plan for basic services, land use planning, and also public services, and most importantly, public transport based on this. And because of this, I mean, there is a lot of leapfrogging of public services and also of population and employment in the peri-urban parts of India cities. And because of this problem with the master planning, basic services are not planned well in advance. And also, as some of the existing studies on India have already pointed out, public transport remains largely confined to the central city. So the suburban and the peri-urban areas are completely left out. So these are some very important reasons and policy motivations as to why we should understand the suburbanization of the spatial structure of India's cities. So the objectives are to find out if India's cities are suburbanized, one. If yes, what is the extent to which they are suburbanized? And the second question is, are there regional variations in the suburbanization of India's cities? And the third part, so these first two questions I answered today in the presentation, but the third bullet the causes of suburbanization in India's cities, and are they the same as those that explain the post-war suburbanization of cities in the US? That is something that I do not get to because that part of the work is not complete yet, right? And so what we do is that now try to understand the theoretical framework for understanding suburbanization. So this picture should be viewed as, everybody is able to see this picture, right? This picture should be viewed as one quadrant of a circle, right? The city is assumed to be of a circular shape. And this is central business district, 0 miles from city center. This is the edge of the city. And we have two curves here for two different cities. And this is the spatial distribution of population. So here on the y-axis, we measure D of R, which is the population density at distance 1 kilometers, 3 kilometers, 5 kilometers, 7 kilometers, or miles, as the case may be, from the city center. And this is the population density function of city 2. And this is the population density function of city 1. And what we find here is that city 1 rather, this 0.4. City 1 has a lot lower absolute value of this gradient. So the slope of this function is called our population density gradient. And this is an absolute value lower than this one for city 2. So city 1 is basically said to be more suburbanized when compared to city 2. So this diagram shows the suburbanization as a B suburbanization, right? B suburbanization is a process by which there is a decline in the absolute value of the density gradient, because that way the curve flattens, right? Flattens. So you, as you can see here, city 1 has a lower value of the density gradient, but it's also a lot more spread out, having a radius of 11 miles when compared to city 2, which is a lot more centralized with a higher value of the density gradient. And it also has a shorter radius of about 6 miles. And this is a very, very data intensive process, and this B suburbanization. And I'll tell you what we can do in order to get around this data problem, right? Because we need, in the previous slide, as you saw, you want data on a number of different pockets on population, land area, city center, and distances of various areas from the city center. So it's very, very data intensive. So the 2-point gradient technique basically depends on 4 points in every city in order to calculate the density gradient. In this standard exponential population density function, we estimate the density gradient. Here we calculate the density gradient. Basically, this is the central city, the blue circle, and the green concentric circle is the large metropolitan area. And the 2-point gradient technique relies on a method by which you take the circumference of a circle, which is 2 pi r, and you integrate over the density function, which is d of r. And then when you integrate this density function with respect to this, you get one expression for LC. LC refers to population of the central city. RC refers to radius of central city. L refers to population of the entire metropolitan area. R refers to radius of the entire metropolitan area. So now, you do this integration, just summing up of population density over the inner circle, you get LC, and this is one expression you get. And you do the same thing for L, right, for the entire metropolitan area. And the ratio of LC to L basically gives you this equation, which does not have a closed form solution, but it is a single equation and a single unknown B, right, which is our friend gradient, right? So Edwin Mills basically developed this technique to demonstrate how one can get around the data problem, which is frequently encountered in the estimation of density gradient. So this is, however, one should understand that there are some problems with the calculation of the density gradient. It does not provide any statistical significance of the model, and it also does not provide any confidence interval for the density gradient to lie. All right. So those are two, and it is based only on four points in a city: LC, RC, L, and R, as opposed to the estimation approach, which is based on numerous points at the city level, sub-city level. So now, existing literature and our own study, there is a lot of literature on this suburbanization. So Mills and Price, I mean, Alperovich actually is a very interesting paper, because he basically demonstrates that the higher the R square in an estimated density gradient equation, the higher that is really the real city center. That is the way in which you go about identifying the real city center, the R square. So that is the primary finding from his paper. And Mills and Price basically 1984 estimated this for all the US metropolitan areas, and found that the central city flight from blight is a very poor explanation of the US post-war suburbanization. And Miskowski and Mills basically talked about two theories. One is the central city flight from blight, which means the central city is characterized by poor quality of public services, pollution, high taxes, higher level of crime, congestion, and so forth. And because of which households would like to suburbanize. And the natural evolution theory, basically about which they talked, relies on transportation technology, income, and the preference for households to move away and consume more land as they become more and more rich. So that is the primary contribution. That's the Journal of Economic Perspectives paper. And Gleiser and Kahn. I know Matthew Kahn is associated with USC now, so I was hoping that he'll attend the presentation. I don't know if he's here, but what I want to just point out is the Gleiser and Kahn paper is very interesting, because they looked at the suburbanization of employment in American cities, and they basically found that 85% of the employment in American cities had already suburbanized by the time that they did the study. And they found that primarily it was confined to suburbanization of manufacturing employment. And Bruckner and Franco basically looked at the distortions introduced by employer-provided parking incentives for suburbanization in US cities. And our paper here is most close to Berthaud and Malpesi 2003, in which they looked at the spatial distribution of population in 48 world cities. I'll talk a little bit more about it. I'll actually talk about it throughout. And there are various papers talking about suburbanization of various cities across the world. So I will not talk about them a lot. So Indian cities, Duval and Mankonen, they estimate the population density function for Chennai, India, and they find that Chennai indeed suburbanized, and they summarize the implications for Chennai's real estate. And also into my 2007 Regional Science Urban Economics and Urban Studies paper, I used calculated density gradients because I could not get the data to estimate them. And in my paper with Matthew Hollian, also we calculated density gradients, and this for all Indian cities. And in my paper with Priya Narayanan, we estimated the density gradients, population density and employment density gradients for Gulbarga, which is a small town in Karnataka. And Munshi et al., they did not look at suburbanization. They just looked at how employment in Ahmedabad, in the western Indian state of Gujarat, had actually gradually moved away from the city center. So this study, how is it different from the existing studies? This study is based on data from the Global Human Settlements Layer, GHSL, and it's based on sub-city level, sub-kilometer level data, both for 1975 and 2015. And we estimate population and we estimate employment density gradients. We don't calculate them like the past studies have done. And we also examined regional variations in suburbanization. And Professor Green, at the beginning of this talk, very importantly mentioned that regulation, zoning, and they are actually policy They are a lot more important than market forces in determining the urban sprawl of cities. And he's absolutely right. And I could not appreciate that more. So in order to demonstrate that, I'm not going to be able to explain the underlying causes of urban sprawl in India cities, but we'll just try to merely correlate some of these variables with the density gradients before we move on. Now, what I would like to just show you is to give you some idea of the estimated population density functions from Berthaud and Malpesi. And this is the population density function for Los Angeles. And it is a negative exponential function showing that population density declined very gradually as one moves away from the city center, and the density gradient value is quite low, which is it's almost zero, but not quite minus 0.03, which means it's quite flat, right? So it's very, very slowly declining. And here you see Brasilia, and here there's a positive exponential density gradient, and Brasilia is a very strongly planned city. So its population density gradient is also relatively flat, 0.04, but a little bit more steep than Los Angeles, and it is a positive exponential. Just to show all of you some examples of what the numbers look like for other cities in the world before I present all this for India cities. The data and methodology for our study, as I said, primarily extracts, depends from Global Human Settlements layer, published by the joint European Commission. And population density functions were estimated for nearly about 333. We estimated about 350 regressions, right? So this is for 139 cities for 2015, for which the data were available, and also about 87 cities in all Indian cities, 87 cities for 1975. And this 1975 work is not yet complete. So that's still going on. But as of now, about 350 regressions we have estimated, taking into account population, employment, and household density gradients, and for both years, wherever the data were available. And what did we use as a city center in each case? We used either the city's railway station, most likely, or the city bus stand, or the state secretariat, or the municipal office, or some other landmark where these were not actually suitable. And employment and household density gradients were estimated only for 60 cities. And this was based on data from the Census of India. And for those of you who know, the GHSL does not give any data on employment or households. And the main constraint for estimating employment density regressions was the lack of data on land area at the sub-city level. So here, this is a picture, a map of India for those of you that have not visited India or know its geography well. So this map of India shows, this is Karnataka and this is Bangalore, where I'm based. And this is a newly carved state called Telangana, of which Hyderabad is the capital. This is Andhra, Tamil Nadu, Kerala. Tamil Nadu and Kerala are important because they are some of the most urbanized states in the country. So these 4 states, actually 5 states, are defined as the southern states in this study. And the urbanized states are Gujarat, Maharashtra, along with all the southern states, plus West Bengal. They are defined as the urbanized states. And the lagging states are Bihar, Jharkhand, Uttar Pradesh, UP, Rajasthan, and Madhya Pradesh, along with Chhattisgarh and Odisha. These are states which are whose per capita income is growing really very slowly compared with the national average. So these are defined as the lagging states. So these are the basic classifications and categories as far as the research here goes. So these are all estimated population density gradients for the largest Indian cities. And this is a population density function for Mumbai, this for Delhi, this for Chennai, this for Kolkata. And it's very interesting to find that the population density function for Mumbai and Chennai is exactly, they have the same slope, the same density gradient, minus 0.08. And Delhi is 0.09, and Kolkata is the one that is actually the most centralized, right? At a negative exponential density gradient of minus 0.13. Now,
So,
yeah.
I'm sorry, Kala, can you go back to that LA density gradient? I just want to compare that number to the.
That is 0.03.
0.03. Okay,
Yeah.
thank you. I thought it was, okay, this makes sense. I thought in absolute value it was larger, which was going to surprise me, but no. So, thank you.
Yeah, thank you. Thank you. So what we do next is, I'm not going to go to individual cities, but I'll try to summarize the distribution in terms of just the average, maximum, and minimum for each of these estimated population density gradients for 2015 for all Indian cities. And this is the average for 139 cities. And this is the absolute value of the density gradient. So I will talk about this later, but very few cities had actually positive exponential density functions, only a very few. So most of it were negative, and the absolute value was 0.48. And the city names are given here for the maximum, and this is the most suburbanized, right? The lowest absolute value, 0.01. And I was, happy to note that Varanasi in UP, Uttar Pradesh, was one of the most suburbanized in 2015, because I think that this was the Prime Minister Narendra Modi's home electoral constituency in 2014 for the first time. So it received a lot of infrastructure ahead of that. So no doubt that when your infrastructure is very strong, the suburbanization also increases, right? Because people find it easier to move out and live and then still commute to wherever they want to. So that probably explains this. And Kolhapur in Maharashtra, one of the most urbanized states, this was actually one of the most suburbanized also in 2015, based on the estimation of density gradients, because I found that there is a infrastructure in the central city that was really stressed, right? So that's the reason why probably, which explained the suburbanization that we observe here. And side by side, actually, I also compare the calculated density gradient. Actually, we had the calculated density gradient data from 2 years, 1991 and 2001. And I just randomly, because it belongs to the 21st century, I just put a 2001 to compare with 2015, and the 1991 density calculated one to compare with the 1975 estimated one. So here is a calculated. So what we find is that the maximum with the calculated density gradient is actually a lot lower than it is with the estimated one. However, this is basically the same. So I found also that the calculated density gradients have actually a much lesser standard deviation, which is to be expected, and there's also no confidence interval and no statistical significance. So I have a lot more confidence in the estimated ones, but just to show you how they compare with the calculated ones. Now, these so what happened in 1975 to the population density gradient for all Indian cities? So the estimated one for all Indian cities is 0.54, right? Whereas for 2015, it's 0.48, which means Indian cities suburbanized from 1975 to 2015, right? And when you see the calculated density gradient for 1991 and compare it with the calculated one for 2001, obviously there was some suburbanization also, because from 0.37 to 0.35, right? So that also indicates suburbanization. So we did a correlation of the estimated density gradients with the calculated ones, and they are positively correlated, as we would imagine, but with the associated caveats with the calculated ones. And what we found here, see, I think for every slide, I want to make sure that we are worried only about the cities that are sprawling, and we don't worry a lot about the cities that are compact and efficient. So here, Guwahati in Assam, which is a northeastern state, is actually the most suburbanized. And I found that it has a very disconnected street network. disconnected street network in the sense that the curviness and the tree density and all those things are taken into account. And there is a score also provided by this particular index, and higher the score, the more disconnected the street index is, and the more disconnected the street index is, the more difficult it would be for people to live closer to each other. And so they suburbanize. That is the standard kind of assumption with this. So now, summary of population density gradients for 2015, South Indian cities, South Indian cities. So what happens when we examine these things for South Indian cities is that the South Indian cities, I find, are a lot more compact, right? A lot more centralized, because this absolute value of the population density gradient was 0.48 for all Indian cities, whereas for South Indian cities, it is 0.66, which is significantly higher. And the maximum and the minimum is here. And when we compare this with the calculated density gradient, the calculated one indicates a sprawl for South Indian cities, which I'm not sure by. But as I said, for many cities, we were not able to calculate the density gradient because that equation does not provide a closed form solution always, right? So there could be a problem there. And here, when we estimated Malappuram in Kerala, this is the most suburbanized, and I checked on the disconnectedness of the street index score, and this was really quite disconnected also. So that is probably one reason why and how this is the most suburbanized of all the cities. So what we want to do is look at what happens for South Indian cities in 1975 is that the South Indian cities, even in 1975, were more compact when compared with the all India counterparts, as may be seen in this average value of the estimated density gradient. And you find that Visakhapatnam, which is actually a coastal city on the eastern part, was the most suburbanized. And coastal cities, I think there is a bit of reason why we may expect them to be more suburbanized than the others, because they have limited geographical constraints, as also what Professor Green pointed out at the very beginning of this talk, is that they have geographical constraints. They cannot really expand in the east, but they can only expand in the west. So that is what I think explains the suburbanization of Vizag, whose population density function you see here. Now, what happens to the urbanized states, cities in the urbanized states? All these urbanized states, as I explained earlier, are those which had an urbanization rate higher than the national average in 2011, which was 31.16%. So when we see this, the most suburbanized again is a town called Kolhapur, which is famous for its sandals in Maharashtra. And this again, as I explained earlier, is characterized by very stressed infrastructure in the central city. And while in the in 1975, the population density gradients for South Indian cities were actually the result from both the calculated and the estimated pointed to compactness. Here, for the urbanized states in 2015, the calculated and the estimated point to opposite directions. Although this is actually very small of a change in the density gradient to consider that sprawl. It was marginally on average lower than what it was for all the cities. Whereas our estimated density gradients clearly indicate compactness of the urbanized states, the cities in the urbanized states, because they are most likely aware of the costs of infrastructure development and land costs. And so they try to be more compact and economically efficient, which is probably least expensive. Now, what happened to the population density gradients in 1975 for the cities in the urbanized states? And you find that I mean, there is a very, very marginal change. However, we could say that there was sprawling in 1975, but they became compact in 2015, which I demonstrated in the previous one. And the most suburbanized here is a city called Jalandhar in Punjab, which is north of Delhi, the national capital region. And although Punjab is defined as an urbanized state, it's very, very rich agricultural state, and it has some excellent infrastructure in the form of highways. So this presumably explains the urban sprawl of this particular town, which is the most suburbanized. Now, what happens to the population density gradients for cities in the lagging states, right? Lagging states. So what we observe here is that they sprawled, right? Compared to cities all India. So this is the value of the density gradient for all India cities 2015, if you remember. And this is the value, average value of the estimated density gradient. And what we find here again is that the Prime Minister's constituency, electoral constituency, Varanasi, continues to be the most suburbanized. And we find that the calculated value, I mean, this is well possible that this is compatible with this, because this is for 2001 and this is for 2015. So it's possible that from 0.40 to 0.48, this may have become compact, but we don't know that for sure, right? Because we are not able to estimate these density gradients for 2001. And so the calculated result gives us a different finding than the estimated one, but it's very, very possible and plausible to believe the sprawling result, because all the lagging states are actually not very urbanized, and so it's likely that they are not yet experiencing any costs of developing infrastructure. If they have the land, they just like to spread themselves out rather than be compact and efficient. This is a summary of population density gradients for cities in lagging states. And what we find here is that even in 1975, these folks were actually compact as compared to all India, whereas they became sprawling in 2015. And you find that the most sprawling city here amongst the lagging regions is a city called Kota in Rajasthan, which is actually famous for its coaching centers for students to get into professional colleges like medicine and engineering. And there are two reasons why probably Kota is sprawling like this. One is that it has excellent infrastructure, although it's in a lagging state. And second is that it has a very disconnected street network, as I explained to you earlier, in terms of the curviness of roads and tree density and so forth. So those are two reasons that explain this. Now, we come to employment suburbanization, which Gleiser and Kahn looked at for American cities. And what we find is that employment suburbanization, employment density is a lot more centralized, a lot more compact when compared with population decentralization. And this may be seen in the absolute value of the density gradient for population, which is 0.5848, whereas 0.68 for job suburbanization. See, this makes, I think, sense, because employment suburbanization, employment is dependent on the availability of raw material, inputs, talent, proximity to market, and so on, right? So it is dependent on a lot of contingent factors, which is the reason why it's a lot more centralized. For one reason, and we also found in our earlier work in 2007 that manufacturing was a lot more suburbanized than services suburbanization, which is the same result that
you asked me for a time check, so here is your time check.
Oh, okay. I have 9 more slides, but I'll rush through them. Thank you. So what I do here is, I just want to point out here that these are the employment density gradients for South Indian cities. for 2015. And lo and behold, South Indian cities, as we find in the case of the population gradients, that their also employment gradients are much more compact. And the most suburbanized here is a small town, coastal town, again in Karnataka, as I mentioned. Coastal towns have this tendency to be more sprawling because this is also Asia's largest naval base. So, and it has some excellent roads and highways, which is the reason why it probably sprawls. So this is a summary of employment density gradients for cities in lagging states. No doubt here, both our calculated gradients and our estimated gradients indicate sprawl, right? Sprawl. So this is 0.68 for all cities in 2015, whereas for the lagging states, cities, this value is only 0.3, right? And this particular town in Bihar is one of most India's lagging states, is the most suburbanized. And I found that the primary product that is exported out of this region is plywood, and it tends to be land intensive. And this could be probably one reason why it is sprawling. So what does a summary of employment density gradients in urbanized states indicate? And this is again our coastal town in Karnataka, which is Asia's largest naval base. And this is again definitely more compact because urbanized states are aware of the cost of leapfrog development. So they try to be more compact and efficient. Now, this is the summary of population and employment density gradients for the largest Indian cities. So these are, this is the estimated and these are calculated employment density gradients. And this is the estimated employment density gradients. So what this basically shows is that Delhi significantly suburbanized, and so did Mumbai, and so did Chennai, right? And Bangalore definitely did suburbanize, and this is the population part. And because I live in Bangalore, I know this process quite well. And Ahmedabad actually in between seems like it's centralized and centralized again, but again, these are calculated, these are estimated, and Hyderabad also significantly suburbanized. Bangalore and Hyderabad have a very similar story here, which I completely understand. And similarly here, Hyderabad and Bangalore, and Kolkata seems amazingly the same, both years. So this reinforces my confidence in the estimated one as well as in the calculated one for that particular city. Now, these are the summary of estimated calculated employment density gradients for by category. So if we believe this is 1975, this is 2015, these are estimated. And if we just look at this trajectory here, 54.54 to 48 suburbanized, 0.58 to 0.66 for South Indian cities, they centralized. And this is again for the urbanized states, they centralized, and lagging states significantly suburbanized, right? And a very similar story, but here it all seems as if the employment centralized significantly, except in the case of the lagging states. But that could be a caveat of the calculated gradient problem. That could be that. So what is the summary of our preliminary findings? Here, the negative exponential density function is very useful for studying urban form in India. And as I said earlier, in 2015, only 6% of the cities had a positive exponential gradient, and only 9% in 1975 had a positive one, and 10% had positive employment density gradients in 2011. And most cities' population density peaks within the first 2 kilometers of the CBD. And as far as population suburbanization is concerned, the spatial structure of Indian cities certainly flattened during 1975 to 2015. And the South Indian cities and also those in the most urbanized states are more compact when compared to the northern and also less urbanized counterparts. And also the cities in the lagging states sprawl, except as indicated through the calculated density gradients are considered. And employment suburbanization is a lot more centralized when compared with population decentralization. And again, South Indian cities and those in urbanized states are more compact in terms of job suburbanization. And now to get to the point that Professor Green was talking about in the introductory remarks, the role of policy here, right? Land use regulations. So we estimated some basic correlations. We are not ready for any regressions yet, as I said, because the 1975 estimations for all the cities are not yet complete. The calculated density gradients for 1991, 2001 are positively correlated, and the calculated density gradients and the estimated ones are also positively correlated, which gives us confidence in what we have done. And the estimated density gradients for both 75 and 2050 and the population and the employment density gradients are also positively correlated, very highly positively correlated. And what we found was that there is a negative correlation between the estimated population density gradient and the city per capita income, which is part of the explanation of the natural evolution theory. And the same negative correlation we find between job suburbanization and city per capita income. Higher the income, greater the suburbanization, and so on. And FAR, the land use regulations are negatively correlated with positive population density gradient. We would have expected a positive relationship because higher the FAR, higher would be the extent to which a city is compact. But that's not what we found. But again, this is not based on all cities yet. And as Professor Green rightly pointed out, the estimated urbanizable land is negatively correlated with FAR, which is actually exactly what we expected, which means that some cities which have some rivers and mountains and lakes and stuff like that permit a higher FAR because their built area is somewhat constrained to the extent of the natural geographical constraint. And we did not have any measures of central city flight from blight. So we looked at central city density as a measure of this, but we found the unexpected finding that density, central city and estimated population density was positive, but whereas we would have expected a negative relationship, right? Because if the city was compact, then the central city would not be so stressed. And if the central city was actually stressed, then you would expect more suburbanization. So we had expected a negative relation, but we found a positive one. And we also found a negative correlation between agricultural productivity and population decentralization, whereas we had expected a negative relation. So this is my last slide, real slide. The limitation of this is that, density gradient is only one measure of spatial structure of a city, but the most widely used. And the next steps of this process are to estimate the remaining regressions for the 1975 cities. About 40-50 more are remaining, and the explanatory variables are still, we have to put together a data set for that, consisting of FAR, agricultural productivity, and city per capita income, central city density. And I'm committed, as per my Fulbright proposal, to also have an FGD of developers, planners, academics, and real estate realtors on the land use regulations and so forth, that explain what they find. And we also have to do the regressions of population, employment density, and all these exogenous factors. I thank you a lot for your attention, and I'm really sorry for any time overrun resulting from my talk. And I thank Professor Green, University of Southern California, Price School of Public Policy, Lusk Center for Real Estate, and all of you, the audience, for your patient listening. And no doubt a lot of thanks go to Merlin and Chase McNeil and Naina Tibayan. Thanks a lot, and I stop at this point.
Thank you very much. Do we have questions from the audience?
Okay.
So if you have a question, if you want to ask a question, type it in the box, or I'll recognize you, or raise your hand. Chris Redford. So Marilyn, can we just make Chris a participant? So Chris, why don't you just, and while you're doing that, Chris, Marilyn, why don't you just make everybody a participant so we can have a conversation? So Chris, please go ahead.
I saw his question. Should I?
Oh, I see it now too. Chris, you there?
No mic, sorry.
Oh, no mic. Okay, thanks for an interesting presentation.
Okay. Yeah.
I'm curious about the variation in density around the gradient. Have you looked at spatial deviations?
Yes, of course. Actually, I should go back to my presentation if I have to answer this question, because if you remember...
By all means, put it up again.
Okay.
Yep.
See, actually, what I was trying to say is, I did present all these, all these variations in the density function, they are not related to the gradient. They are related to the spatial deviations in population density. And that is how I actually drew this graph. So this is one circle of the one quadrant of the circle of the city, right? And this is the city center that we have designated. And these are population densities at various points from the city center and how they vary. So this is a largely free of the density gradient. So is that your question? Spatial deviations. This is so. So even without the estimation of the regression of the population density function, what these graphs show. I mean, let me go to the things for specific cities, especially the large cities, right? So, so this shows a clearly negative exponential density function for Mumbai, right? And this is a clear negative exponential density function for Chennai. And this is a very symmetric distribution for Delhi. And this is also a very strongly negative exponential density function for Chennai, for Kolkata, sorry. And so these are all not based on gradient. That's why a reason why I put the gradient value, so that you correlate the population density and the spatial distribution to the density gradient. Okay.
So, and by the way, are you going to share your slides with us?
Yeah, certainly. I can share.
I would actually, there are a few I would like to steal for class, of course, with full attribution.
Okay, sure.
That's stealing in academia. I mean, the difference between stealing and scholarship is attribution.
Yeah, definitely. Thank you. I'm delighted.
Let me ask about your FAR number, because that's I mean, it is just a correlation. You haven't controlled for anything, but
no.
It is backward. How much of that do you think is just driven by Mumbai? Because I'm looking at Mumbai and it has a lower gradient than the other cities, and we know it has a notoriously low FAR
in Mumbai.
For what it is. If you took Mumbai out, would that correlation at least go to zero?
Oh, okay. That's a very good suggestion, Professor Green. I haven't done that, but I think I should do that. Mumbai has so for those of you that don't know, Mumbai has a maximum permissible FSI. It's called floor space index in Mumbai of 1.33 in Nariman Point, which is notorious by any standards, right? And what this was not always the case. In 1960s, Mumbai had an FAR of 4, and which gradually declined over time to 1, because initially they realized that the cost of development is higher, and so developers need to recover their costs of development. So a higher FAR was allowed, but as they realized that the planners realized that it was increasingly difficult to provide infrastructure, they lowered the FSI, and what you see is a very small number now. And about 2 years ago, the Mumbai draft development plan for 2025 to considered increasing this FSI to about 8, and there were a lot of civic organizations and NGOs which actually were up in arms against this, and they said that no, we don't want tall buildings and narrow streets. And so I think that proposal has been dropped. And,
the irony of, so they're trying to prevent density, but the people density is there. It's I think the third densest city in the world.
Right. But I mean, that just probably means FSI is not such a great metric to understand density. There could be maybe other measures which enable us to understand the effect of density on infrastructure much better. Maybe that just means that FSI is a poor measure.
So I think Arnab Dutta has a question along those lines. Arnab, you want to ask it?
Hi. So I'm a fourth-year PhD student here. I'm a great fan of your work, Dr.
Oh,
Sridhar.
okay. Thanks.
I just had one question regarding that last slide. Where you mentioned that there's a negative correlation between the floor area ratio restriction and the density gradient. So I'm just wondering, shouldn't there be like a second order effect, meaning that the cities which have lower FAR would probably suburbanize faster than those that have a higher FAR?
Yeah, you're absolutely right, Arnab. That is the relationship that we expected, but that's not as we expected because, see, for one thing, I'll tell you what, this FAR data was gathered for my 2010 paper, but I have tried to kind of update it by visiting the development control rules for many of the individual cities, but still the FAR data set is very, very limited in the sense that we don't have any information about the maximum permissible FAR or FSI in many Indian cities. And that's the reason. But I have got recently, about a week ago, a data set from the WRI on this FAR in all Indian cities, and I have not really had a chance to put that together and integrate that with this data set yet. Maybe if I use that, we might get a negative relationship that we expect, so that cities which allow higher FARs, we expect a positive relationship. So allow higher FARs will be more compact, and cities which allow a low FAR are sprawling, right? So that is the positive relationship that we expect, and we might find that if I use the new data set. I really don't know about that yet. Thank you.
Okay, well, we have come to the top of the hour, so let's thank Dr. Sridhar for a very informative presentation. Again, that slide of density gradients for large Indian cities is one I would love to be able to use in my classes. So
yeah, please do. I'll send you.
Thanks for that. And I am very eager to see, as you further explore the relationship between FSI and gradient, what you get. And just, Nariman Point, for those who don't know Mumbai, is one of amongst the most expensive real estate in the entire world.
Yeah. Absolutely.
So they should be building tall buildings with narrow streets there.
Yeah. I wonder what the realtors and investors, the real estate investors have to say about this. But I certainly want to catch hold of some realtors and developers who deal with housing projects, who invest in housing projects in countries like India and Mexico maybe, and try to understand what they think of the FSI regulations there. So that will give us a lot of insights.
So we will make this available on our website, a recording this. And how long are you in town, Dr. Sridhar?
Yes, I'm here until July 1st. My fellowship, the first segment of my fellowship ends on June 30th. So July 1st, I'm going back to India. And please pray for my safe travel.
Yeah, I will. Have you been, if I may, I probably shouldn't ask you this. Have you been vaccinated?
Yeah, partially vaccinated.
Okay, good.
I got my first dose and I go home and take my second one.
Okay, all right. Well, please do be safe. And
I
look forward to seeing you again.
Yeah.
We're all traveling again.
Yeah. Next year, definitely. Okay. Thanks a lot, Professor Green. I really appreciate this opportunity, and I'm delighted to be part of this conversation at the Lusk Center for Real Estate Research.
Well, it added a lot. It really spiced up the summer. So thanks so much for coming.
Oh, thank you. Thanks a lot. Thanks a lot for all the audience who participated and also the administrative staff who coordinated all this so well. Okay. Thanks a lot.
Take care, everybody.
Yeah, thank you. Take care.
Bye-bye.